Between what is hoped for and what can be, there's a bridge. Between the aspirations of a ball club and the greatest sports venue in America, there's a bridge. Between chaos and wonder, endangered and protected, there's a bridge. Built on technology that can solve, create, heal, inspire, and secure. A bridge. There from the beginning to where we stand today and where we will go from here. One company, one promise. If you can imagine it, we will build the bridge to get you there. Cisco. The bridge to possible.
Demos la bienvenida a Tim Kranz.
Buenos días, Latinoamérica. Yo soy Tim Carnes o Timoteo Carnitas para los amigos. El vicepresidente de Ingeniero Preventa de las Américas. Hablo inglés y un poquito de español, but typically when I visit Latin America, I speak some version of Spanglish. Cisco LATAM has many innovation stories that connect with our keynote speaker this morning. In fact, Mexico was one of the first countries to host a Cisco Innovation Center, and we quickly replicated that model in Brazil. Our next speaker has 30 years of networking industry experience, and he brings to his current position at Cisco as Vice President of Corporate Strategic Innovation Group. He pioneered the Internet of Things before IoT was even a buzzword, and has led dozens of IoT projects across multiple different industries. He continues to incubate new business models and is passionate about driving co-innovation at Cisco. Known as a practical visionary, he's one of the faculty at Singularity University and the author of Building the Internet of Things, a New York Times bestseller. In fact, a copy of his book is available in both English and Spanish right outside at the Cisco store, so please get a signed copy. Y por favor, demos un gran aplauso a Maciej Kranz.
Good morning, everybody. Thank you so much for getting up this morning and showing up here in person, knowing how wonderful the parties were last night. Woo! Despite the rain. All right. So for the next hour, let's talk about how we can create transformational value by connecting technology and people. If there's one message that you get over the next 60 minutes, it is that transformational technologies like Internet of Things, artificial intelligence, blockchain, fog computing, and integrated with the network are not just the buzzwords, they're not just a vision, they're not just a future. They're here and now. And there are thousands of organizations across the globe that are using these technologies, integrating them into the network, together with the innovation programs, together with the ecosystem programs, to improve their operations and to transform their businesses. And in the process, they're transforming our lives. So you know I have 4 kids. All of them were born in the San Francisco Bay Area. And my oldest son is a journalist. He is actually in Beirut right now reporting on Middle East politics. And him and I would often have a debate and a discussion about the major ills of the world. You know, the big stuff, hunger, poverty, skills gap, government corruption, global warming, cyber wars. And of course, we will be debating what are the best ways for us to solve these problems. And as you would expect, my lens will be focused on technology and how we can use technology to solve these problems, but my son's focus is quite different. So somewhere during the conversation, him and I will be debating these topics, and he will make a statement like, you know, Dad, you Silicon Valley people, you think you can fix everything with technology. And my answer would typically be, well, Sam, I don't think we can fix everything with technology, but I think we can come pretty close. And I truly believe that. You know, this is actually my picture from 30 years ago. When I was my son's age, I also didn't think that technology can do much for us. And then I moved to the Valley, joined the internet revolution, and joined Cisco. And I saw over the last 30 years an amazing impact that the network and the network-based technologies had on us as individuals, on us as businesses, and on us as a society. I saw how networking pretty much changed every industry. Think about manufacturing and solutions like preventive maintenance, like remote asset management. Think about our cities, how we are implementing intelligent buildings and intelligent transportation systems, even intelligent garbage collection. Think about the explosion of agtech, of agriculture technologies over the last couple of years, dramatically improving the efficiency and the quality of our food. And healthcare and retail, every industry has been transformed thanks to the networking technologies. Let me give you a few more specific examples. So Harley-Davidson, all of us know the brand, right? A very iconic brand. So Harley, a couple of years ago, they looked like an archipelago of data islands. So on the manufacturing floor, if you looked at the data flow, the data wasn't actually flowing from one station to another to another. So as a result, if Harley wanted to introduce a new configuration of a custom bike, it would take them up to a year and a half, up to 18 months to do that. So then a couple of people in one of the factories of Harley-Davidson got together and decided to fix it. They were actually from different walks of life. So they were people from operational technology and from IT and logistics and finance. And the first thing that they did was to fix the problem on the manufacturing floor. They connected all the stations on the common network, and then the data started flowing. And then once they've done that, they actually connected the entire process from ordering all the way to delivery. And the results were spectacular. They were able to reduce the time to introduce a new configuration of a custom bike from as long as a year and a half to as little as 2 weeks. They were able to reduce the time to fix problems on the manufacturing floor from days and weeks to minutes. And in the process, they improved the bottom line by 3 to 4%. Pretty dramatic, right? All right. So let me take you now, for the next example, let me take you to central India. This is actually one of my favorite examples because, first of all, it's very simple. But second is because it actually underscores the need to be local and hyper-local. You know, it's not usually the best idea to take, let's say, a solution developed, let's say, in Germany, and without any modifications, just drop it off in India and see that it works. You need to actually start with a business process, with a business problem, with a business environment, and then figure out how to use the technology to solve it. And that's exactly what happened here. So in this example, it is a 150-store ice cream chain in central India. And over there, they have a problem that occasionally they get power outages. So in these stores, it actually can create a problem, right? Because when there's power down, then ice cream will melt. And the company was actually losing lots of money as a result of that. But more importantly, they were actually creating a health hazard because of melting, freezing of the ice cream. So what the company did is they installed generators in each of the store, but savvy managers sometimes will not turn the generators on. Sometimes the outage will happen in the middle of the night. The long story short was that it wasn't working for them. So what they did, in addition, they dropped self-contained temperature sensors into each of these fridges, connected them, of course, to the network, and then to the communication system. So now, as the temperature would start going up, the manager of the store will start getting the message, well, maybe you should check and close the door of the fridge, or maybe there's a power outage and you should turn the generator on. If the temperature would continue to go up, these messages will get escalated eventually all the way to the CEO. Again, a very, very simple solution. And what I love about this sort of a remote operations, remote asset monitoring and management solution is that you can actually surgically implement it without changing the rest of the infrastructure. But the results were spectacular. The company saw 500% return on investment in the first 12 months of operation. All right, 2 more examples. So now let's talk about manufacturing. So General Motors and Fanuc. So GM uses roughly 30,000 robots across their operations. And usually the way it works is that when GM wants to build a new assembly line, they would work with Fanuc and other integrators for a couple of months, specing the line, then probably another couple of months or even a year or 2 to build a new line. And then Fanuc and the integrators would leave and say, hey, call us if you have a problem. But General Motors actually approached Fanuc as well as Cisco, as well as Rockwell Automation, and said, okay, what if we started connecting these robots? And they did. They started connecting the robots, connected roughly half of them so far, and started getting information from the robots and optimizing their processes as a result of getting that data. And GM is reporting that over the last 2 years, by using the data and optimizing their processes, they were able to reduce the number of outages on their assembly line by roughly 100. And each of these outages would cost General Motors roughly $2 million per occurrence on a system-wide basis. So you can do the math, right? Pretty impactful application. So the last example I wanted to give you would be in mining. You know, a couple of years ago, I visited an open pit mine. It actually is a formidable site. You are usually in the middle of nowhere, and there's like this big hole in earth, a couple of miles across, 1 mile deep, and there's these little specks going around the edges. And these little specks are actually these huge hauling vehicles. They have a tire that is actually taller than a human being. And by the way, a set of these tires costs more than $100,000. And as with the previous examples, the problem that the company has been trying to solve is what happens if one of these vehicles actually breaks down. In the case of an iron ore mine, it would cost the company roughly $2 million of lost revenues for every day of one of these vehicles not being operational. And by the way, the only way to pull this vehicle out of the pit is to use another vehicle like this, so your cost actually doubles. So what did they do? Well, they got networking to help them. They installed around 70 sensors on the vehicles themselves, started to get the data, and started to use the data not only to analyze the operation, but actually anticipate the problems before they happen. So they used preventive maintenance solution in this mine, and they were able initially to anticipate roughly 80% of the problems up to 3 months in advance before they occurred. And then a couple of years later, once they actually had enough data, they started using deep learning, and the numbers last time I heard were in the upper 90s. Just to think about it. The company was able to anticipate and prevent 96, 97, 98% of the problems with these vehicles before they occurred. And think about the savings. Prior to the solution, it may take them days or even weeks to fix this vehicle. You know, they would have to identify what the problem was. They would have to order parts, fly the parts in, install it. now they can actually, because they get advance warning, they can actually take this, this vehicle to the shop and fix the problem before it occurs. Pretty remarkable. All right, so when you think about all of these examples, they actually have one thing in common. They are actually examples of the network and Internet of Things working together. They're not just connecting people, they're connecting things as well. And IoT is actually one of the 4 transformational technologies that I want to highlight today. So in a nutshell, Internet of Things is about everything getting connected. Connected to each other, connected to the network, sometimes connecting to the Internet. You know, when you think about the first wave of commercial Internet, now around 25 years ago, and so for the last 25 years, the main purpose of us connecting all of these devices that we are so addicted to was to give us people access to each other, access to the online data, access to the online processes. The main reason we are connecting IoT devices is very different. Their main goal, and the main goal for us to connect these devices, is to capture the data that these devices generate, analyze this data, turn these systems into solutions that drive the business outcome. All right, so now we talked about IoT. So the next technology that I wanted to highlight is called fog computing. So how many of you have heard of fog computing? All right, pretty good, like half of the folks. Perfect. All right, so when you think about the cloud, centralized cloud or centralized large data centers, they're actually good for many things. If you're an oil and gas company and you wanted to analyze 30 years of seismic data, because now you have a more efficient way of getting the oil out of the ground, you can run it in the centralized cloud, and it actually works very well, right? It's a batch processing kind of a function. You know, last week I was actually in Japan, and over there they connected a couple of million of vending machines directly to the cloud as well. And it works very well because what this vending machine does is it sends a couple of packets every couple of days and saying, hey, come on over, I'm running out of cans, right? So it's a track roll optimization kind of a use case. And because there's not a lot of bandwidth required for this function, and that this communication is not very time sensitive, you can connect these vending machines directly to the cloud, and it works very well. But now let's think about an oil rig. So an offshore oil rig, a large one, would have around 100,000 sensors on it, lots of sensors. That collectively generate, I would say, around a couple of terabytes of data per day. So when you think about it, especially if oil rig is connected using, let's say, satellite communication, it doesn't make any sense to take this raw data, send it to the cloud for processing, right? So instead of sending the data to the cloud, we need to send the cloud to the data. We need to extend the cloud capabilities to the edge, right? This is the whole concept of multi-cloud. So in this case, let's say a very simple example. Let's say you have a temperature sensor somewhere on the drill, and you get a policy from the cloud that says if the temperature is 100 degrees or less, please just index this data and store it locally for future data mining. If the temperature exceeds that threshold, please let me know immediately. Send an exception or alert to the cloud, because I actually need to take action. Another example is an ambulance. So a connected ambulance actually is pre-wired so that when the patient gets into the ambulance, you can start getting all the vitals from the patient. And again, the same rules apply, which is you get an exception or an alert. So the vitals that are not normal, you can send them to the emergency room. And then when the patient arrives, hopefully by then, the doctors can actually correlate the information they got from the ambulance and the patient's health records, assuming the patient gave the prior permission or the family gave the prior permission to do that, so that they actually are ready to save this patient's life. So that's fog computing. Now, let's move to the third set of technologies, artificial intelligence. Probably the most overhyped of all the four of those. All of them are hyped in some way, but AI is probably the most overhyped and probably the most controversial. So there's a lot of debate whether artificial intelligence is actually a friend or a foe. I actually believe that AI is a fantastic technology, a fantastic set of tools that can help us as people, as businesses, and as a society. But with every transition, every major technology transitions, as a result of artificial intelligence, some of the jobs will be created, some of the jobs will be lost. And we need to make sure that we help people whose jobs will be affected. But if you think about artificial intelligence, you would expect that at Cisco we actually have hundreds of experts that are using AI, like for example, natural language interfaces, building these interfaces on our collaboration products. They are using deep learning to automate and orchestrate the network. We actually running live on this network here a capability we call encrypted traffic analytics. Actually, John and Karen mentioned it on Tuesday. It is actually a magical, almost magical capability. We are able to identify malware in fully encrypted traffic. But in the context of a conversation, the business conversation we're having, so let's talk about self-driving vehicles. So a level 3 or level 4 self-driving vehicle will generate somewhere between 2 and 4 petabytes of data per year. Just think about it. 2 to 4 petabytes of data per year per car. So of course, like with an example of an oil rig, it doesn't make any sense to send all this raw data to the cloud for processing. So you need to have the network and sensors and IoT and fog computing. But in addition to processing the data in the car itself, we actually need to make decisions instantaneously, right? Our lives depend on it, right? So that's why we need to run AI systems, especially inference systems, in the vehicle itself. So when you think about AI training, probably for the foreseeable future, we would see the training will continue to be done in the cloud or in the large data centers because you need to actually feed lots and lots of data to train the algorithm. But once the AI engine is trained and we want to run an inference process, for example, in the car itself, this technology is actually getting cheaper and better very, very quickly. In addition to running AI systems on the GPUs, we can start running them on FPGAs and ASICs, even on the sensors themselves. And the power consumption is actually, power requirements are going down dramatically as well because these processes are actually much more efficient. And of course, it's important because most of these vehicles actually are going to be electric vehicles. So let me grab a bottle of water here. Let me give you another example of all of these technologies in action. So for this example, let me take you to Spain. So in Spain, they have a problem. A train company over there, they have a problem of competing with low-cost airlines. And they've been losing a lot of passengers to these low-cost airlines. So they decided to fight back. Sorry, getting emotional here. They started to fight back and installed a high-speed train line between Madrid and Barcelona. But the key to their value proposition was that they guaranteed to the passengers that if the train is more than 15 minutes late, they will actually refund all the tickets. How did they do it? Of course, they installed sensors along the line, along the tracks, but they also installed the network, IoT, fog, and artificial intelligence on the engine, on the train itself, so that they could optimize the operation of the train, but also run preventive maintenance on the train as well. And as the company told me, they actually did 2,000 runs of this line up to date, and only once the train was actually late. And in the process, they actually were able to attract a large number of passengers back from low-cost airlines to the train. They claimed that they actually got additional $100 million of revenues. All right, so now that we've talked about the network, IoT, fog computing, and artificial intelligence, let's talk about blockchain. Probably the most misunderstood of the four transformational technologies. But in a nutshell, blockchain is a distributed ledger that multiple parties, multiple organizations can use to easily and permanently write transaction actually in it, the transactions that happen between these organizations. So let me give you maybe two examples of blockchain in action. So the first one, when you think about, let's say, strawberries being planted in Mexico, or blueberries out of Chile, or a lettuce out of California being shipped all the way to the store near my house. You know, on a global basis, up to half of the food that we produce actually gets wasted, gets spoiled, because of the impact of environmental conditions like excess temperature and the moisture and vibration and so forth. So now with the blockchain, we can record all of these environmental conditions as the blueberry is being transported from Chile to a Safeway next to my house. And if these blueberries arrive rotten, we know exactly where on this journey the problem was instantaneously, and we can fix the problem. Similarly, a couple of weeks ago, we had an E. coli outbreak in the US, and it actually has taken a day or actually even a week or two to identify exactly which farm this lettuce came from. So think about it. Same rule applies now with blockchain, because we have one single source of truth used by multiple parties. We can identify instantaneously, in a second, where exactly this lettuce came from and where the source of E. coli virus actually is. So similarly, let me show you another example of a track and trace use case used for blockchain. So in this case is blood. Blood is a perishable good as well. Depending on the temperature and other environmental conditions, the blood can last longer or shorter. So when you think about the application of blockchain here, we can now, again, similarly to the fruit, we can now record all the environmental conditions that the pint of blood was exposed to during transportation. So when the doctor is making a decision whether they want to use this blood to save somebody's life, they will know exactly whether this particular bag of blood is still good, because they actually have a history of the exposure of this blood, or maybe they should use another bag. So the third example that we wanted to highlight is counterfeits. Counterfeiting is a huge problem. Pretty much every company that is producing something, whether it's physical good or software, they're exposed to counterfeits. It is roughly a $500 billion problem around the globe. And we at Cisco actually have this problem as well. So I wanted to now invite Anup Nanra, who is leading a blockchain initiative at Cisco. And Anup will actually tell us more about how we're using blockchain to identify the counterfeits and and actually show us a demo. Hopefully it works. Anup?
Thanks a lot. So we wanted to, thank you. So as Maciej just mentioned, we have a gray market counterfeit challenge at Cisco. Just like every other electronics industry, it's a $500 billion problem. And so we said, how do we actually leverage the technology in such a way where we can actually start stemming the gray market counterfeit challenge that we have? And so this is a live demo. Everyone say hi, right? And what we did is we built a solution, we built technology, we deployed it around the world. It's integrated within our vendor ecosystem. So our supply chain ecosystem, vast, diverse as it is, we're now actually collecting real-time telemetry directly off of the manufacturing facilities of folks in our ecosystem that manufacture optical modules, right? So this is one of the most counterfeited products that we have. Now, actually looking at this, we said, okay, how do we actually get the real-time telemetry off the assembly line, off of the IT systems, and how do we actually get that in a shared version of truth that is shared across our ecosystem? So the entire ecosystem has the ability to have the right amount of transparency to determine whether or not one of these is actually fake or counterfeit or is a gray market product. So I'll scan one of these, and let's see if it will focus correctly.
Do you need help?
I think we're good. Demo gods. There we go.
It usually works.
There we go. So scan 2 codes. Scanning 2 codes, and this one is a fake because there is no entry in the blockchain network, right? This did not come from any provider, any vendor, any supplier within our ecosystem.
That
So it's a
looks
fake.
genuine to me.
It looks exactly the same as a real one. So let's actually now see how a real one might look like. So just from a quick inspection, you might say, well, these all look the same. And so let's actually take a look at the data that we might get off of a genuine one. So we scan one code, we scan a second code. This one is legitimate. This one is real. Not only do we have the verification of the label, the module itself, but we also have the full genealogy and the chain of custody of the asset. We know where it was manufactured. We know where the parts came from. We know where it went to, who touched them last, where in the ecosystem it went. So we have a full chain of custody. So now the entire ecosystem can actually independently determine the authenticity and the verification of an optical module. So now apply that to automotive, aerospace, pharma, life sciences. Possibilities are endless.
Fantastic. Perfect.
Right.
Thank you so much, Anup.
Thank you.
And the demo worked. So now you saw how we're actually making sure that, that the optical module that you're getting is a real one. And as Anup mentioned, lots and lots of other really cool applications that can help us catch these counterfeits, including probably some of the fashion goods that we all buy as well. All right. So now I was thinking about what would be the best example to showcase all of these technologies in action, and I've chosen a swarm of drones. So when you think about the first generation of drones, it was usually a very simple application. You have a bird going around, collecting a bunch of data, somebody remotely managing or operating the drone. Then the drone lands, you download the data. That was the first generation. The second one got better. So now we started to run fog and AI in addition to IoT and the network, and actually uploading the relevant information captured and processed and determined by these systems to the cloud as the drone is flying around. But then the third generation of drones that we're starting to see, besides the ones that you can actually put a person to and like a flying vehicle, is the swarm of drones. So in addition to a vertical communication, you also get horizontal communication. So now, let's say a dozen of drones can operate as one superorganism using a blockchain as a single source of truth. And we can now start using these drones. Let's say in a deep mine, we can send a bunch of these drones to identify the source of gas leak. Or during a fire, they can actually help us put out the fires, drop the fire retardants. Or during a hurricane, identify people, identify livestock as well. So real great applications of all of these 5 technologies in action. All right, so let me go back to the conversation that my son and I have been having about technology and about the problems of the world. And you know, if you look at these examples that I mentioned, yes, of course, technology was key to that. But in addition to technology, it was also about people. For each of these solutions, we needed people with the right skills, organizations with the right culture, organizations with the right processes, with the right ways of engaging the ecosystem. So if I look at the companies that have been very successful in implementing these transformational technologies, they also had to rethink how they are working with their employees. So in many industries, the typical mode of operation used to be, well, I graduate from school, I come to the job, I am in this job for a long period of time, and the job doesn't change very much, right? Sounds familiar? Well, with these transformational technologies and the speed of evolution of these technologies, now these leading companies are rethinking that model. They are now applying and approaching the jobs in a very different way with a mindset of constant learning. They're helping and investing in their employees to help them grow their skills, evolve their skills, reinvent themselves, and reinvent their jobs. Also, the organizations are working with academia to evolve the curricula as well. So in Wisconsin, I was talking to this organization recently, a manufacturing alliance is bringing manufacturers and the colleges together to develop new curricula. So for example, in addition to a generic data science course, they will create a data science course for manufacturing. And of course, it's a win for potential employers and potential employees. Thirdly, apprenticeships are coming back. Again, for exactly the same reasons. We're actually running an apprenticeship program at Cisco as well. So let me give you an example. So as I mentioned, I live in the San Francisco Bay Area in Silicon Valley, but roughly an hour-and-a-half drive south of San Jose, there is another valley. We call it the Lettuce Valley. It's centered around a city called Salinas. And the reason it's called Lettuce Valley is because roughly 60 or 70% of all the packaged lettuce sold in the United States is actually packaged there. So recently, I went and visited one of these packaging facilities. It's a huge hangar and with multiple lines, packaging lines. And on one side of this hangar was a fully manual line. So 20 or so people were running around and cleaning lettuce and packaging it and working on this manual line. On the other side of the hangar was a fully automated line where only 2 or 3 people were monitoring the line. And the company was going from one side to another and upgrading the lines from manual to automated. But in addition to automating these processes, they also were working with their employees and helping their employees get additional skills. So instead of just working on the line, they were becoming quality engineers and supervisors. And again, it's a win-win. The company is getting more efficient. They are getting a highly qualified set of employees. And it's a win, of course, for employees because they're getting better jobs, better paid jobs in the process, right? So that's the mindset that leading companies are implementing. It's not just about technology. It is about people. It is about helping people evolve and be part of that transformational revolution. There are some other consequences of transformational technologies. One of them is a shift to business models. This is actually a survey from a couple of years ago when we asked you, our customers, now that you're getting all this data from all the IoT devices, how does it impact your business model? And you said that you expected that in majority of cases, you would be moving from a product to service-oriented business model. Why? Because now that you're getting all this data, you can make intelligent decisions. So instead of, let's say, building a new assembly line, you will just rent the capacity that you need, and the savings will go straight to the top and the bottom line. Interestingly now, we are seeing the evolution of this model, of the business model, into microtransactions. So when you think about an airplane engine, the companies that produce these engines, they actually evolved to the utility model a couple of years ago, right? So instead of selling you an engine up front, they would actually charge an airline for the actual usage, the hours that the engine is actually being used. But now, with these transformational technologies we talked about, we can take this model much, much deeper into the products and into the business. An extreme example would be, instead of buying a tire, you can pay a tire manufacturer, let's say $1 for every 50 kilometers that you're actually using the tire. So another consequence, probably one of the biggest consequences of these transformational technologies, is in market structures. So traditionally, if you wanted to build a train station, or if you wanted to build an oil rig, you would turn to one company, a vertically integrated company, and this company will basically put the whole thing for you from A to Z, often using sort of proprietary or semi-proprietary technologies. But also, increasingly now that we're seeing these transformational technologies being implemented, you, the customers, are coming to us, to these vertical specialists, to companies like Cisco, to horizontal specialists, to regional specialists, and saying, hey guys, why don't you all work together and put the solutions together based on open systems, open standards that are interoperable? It's a big shift in mindset, big shift in how the industries are operating. And then on top of that, we also are seeing a big shift in how we are thinking about innovation. So quite often, especially in the large companies, innovation is thought about sort of a side activity. You know, there is maybe innovation HR program, maybe there's a bunch of people sort of tinkering with some of the cool stuff on the sidelines. But again, if you think about all of these changes, the dramatic changes in technology, we're now seeing that the companies are making innovation core, moving the innovation from the edge to the core. And that's what we're doing at Cisco as well. We actually think about innovation in sort of 5 pillars. So of course, we have lots of engineers, we build great products, you can see them in the world of solutions, but we also run programs like a Tech Fund or Innovate Everywhere Challenge. Occasionally we will buy the technology, we will of course partner with you to develop technologies. We actually work a lot with the startups. We have a $2.2 billion investment portfolio. And last but not least, my favorite way of innovating is co-development or co-innovation. We're running a program called Cisco Hyper Innovation Living Labs, or CHILL for short, where we actually bring different companies from completely different industries and give them a problem to solve. And it's amazing when you actually get companies that traditionally will not talk or work with each other, started to brainstorm on a solution, and amazing, unexpected solutions come as a result of that. And one more program that we run, and I'll talk more about it, is innovation centers. Tim mentioned it. I think you did. You spoke in Spanish, but I thought I understood. So innovation centers that we run around the globe as well. So let's talk about Innovate Everywhere Challenge. So we've been running this program over the last 4 years or so. And the main purpose of this program that we run across the entire company was to break the silos, break the barriers across different organizations, and to enable people, like for example, if there is a system engineer in Mexico City and she has a great idea for a new product or a new business because she works closely with you, customers and partners, how do we enable her to actually implement, make this idea happen? So that's, in a nutshell, what Innovate Everywhere Challenge is. It is actually an amazing program. Over half of Cisco employees participate in the program every year. We have hundreds and thousands of teams submitting their ideas, and probably the most importantly, there are dozens of organizations, dozens of these teams that actually end up implementing their ideas for new products, process improvements, or businesses. Let's take a closer look at this program. Let's run a video. I'm really excited today to launch the Innovate Everywhere Challenge.
The Innovate Everywhere Challenge was designed with the employees of Cisco in mind because we know that you have so many amazing ideas that you've been kicking around.
What we're doing is we're giving all of those amazing voices and all those amazing ideas a place to thrive and to accelerate.
The 3 winning teams will get $25,000 so they can spend however they want. They also get $25,000 that they can use to get their project forward. But also, they will be able to take time off their day job and actually focus on their idea.
I think everything here is easily an excellent idea and could be a moneymaker for Cisco.
It's one thing to have an idea, it's a whole nother ball of wax to actually experiment and validate that idea.
We've taken this concept now to customers, and they're asking us to build it, constantly giving us feedback, telling us, that's a cracking idea, you should do that.
We've gotten the opportunity to not only connect with thousands of employees around the globe who were looking to do something similar but didn't really have the ability to do so, to now be part of something bigger.
And we are ready to announce in a random order, 3 winners of the Innovate Everywhere Challenge, and they are
Team EVAR, Team Life Changer, and Team Rainmaker.
All right, pretty cool. I have to say, again, we've seen the impact of this program with so many amazing innovations that got implemented across Cisco. So now that we've talked about internal innovation, let's talk about the co-innovation centers, the external innovation. And we run a bunch of these innovation centers across the globe. I think I listed most of them on the slide. And the main purpose is exactly that, is to co-innovate with customers, with partners, with startups, with academia, to develop solutions that solve the business problems. These centers actually use a very structured process. It's like a funnel going from one side to another. Initially, we would engage with a customer and try to have a conversation around what problems the customer has that we potentially could help with. Then, in the next stage, we would run a workshop where we would go deeper and understand the use case. Then we would try to understand if this use case is specific to the customer, or maybe this use case can be applied broadly across all of the across the whole industry, or even across the industries. And finally, we start implementing these kind of programs. So let me give you a few examples of these kind of solutions that we co-developed in innovation centers. The first one we co-developed with Aeropuerto Argentina 2000. It's a customer that operates around 30 airports across Argentina. And In this case, there was a collaboration with the customer, but also with the partner, with Cisco Argentina, and of course with the Rio Innovation Center. We used a set of tools we call Cisco Events Correlation and Analytics. We used Cisco equipment and third-party capabilities that included location, video, and collaboration. And as a result, we put this solution that optimized the operation of the airport. Some of the examples of capabilities, we can now track all the equipment. Like, for example, we know exactly, or the customer knows exactly where all the wheelchairs are, right? So they can find them and use them. They can locate and communicate with the personnel. So if there is let's say, a couple of planes arrive in one part of the terminal, we can say, or the customer can say, all right, I know where all my people are. They can see like a dashboard, a visual dashboard. Hey guys, why don't you go over there because we have a bunch of planes and they need your help. Probably my favorite example of the functionality is that that now the airports can actually identify frequent flyers and they can offer them additional services as well. So that's the first example. The second one, let's look at a solution we developed in London with Scottish Rail. So Scottish Rail came to us, I think 2 or 3 years ago, and they said, you know, we're operating these high-speed rail connections, but we want to attract professionals to come in and take the train. But during this train ride, we want them to be fully productive, to have an immersive video experience, and to have all the collaboration tools at their disposal. So we did. We worked with a startup, we worked with the partners, we worked with a customer. We developed this solution exactly to solve the problem. And we're in the process of actually deploying it now with Scottish Rail. And once we've done that, there's actually a long list of customers who want to deploy that solution. A third example is in agriculture. We also use the location-based capabilities. We developed a solution in Australia with the government agencies and with the farmers, so that now they can track all of their livestock, they can track all the major machinery. And the interesting thing about these innovation centers is that once we develop a solution in one of the centers, other centers actually can leverage that solution and adjust the solution for the particular needs of their market and their customers. And lastly, Belo Horizonte, also in Brazil, we worked with a city there, a private-public partnership, to install a large solution for outdoor lighting. Not just the LED lights, but actually sensors. So when there's, let's say, in the middle of the night, when there's nobody on the street, we can dim the lights or even turn the lights off and then turn them on when there's a movement, right? Again, a very smart solution to save additional energy. When you think about these kind of solutions, they again are examples of what I call a co-economy, where horizontal specialists like Cisco, vertical specialists, regional specialists actually work together. I firmly believe that in this next wave of digital evolution, actually the companies that are most effective in leveraging this co-economy, they will be the winners. They will be able to produce unique set of solutions that customers are asking for. In addition to co-economy, these solutions are also examples of a change in roles. So increasingly, our customers, our customers, are coming to us and saying, you know, in addition to me buying all of your wonderful products, I also would like to start co-innovating with you. I don't want to just buy your stuff. I want to co-develop with you, right? Because I know my business, I know my environment, you know your technology, so why don't you bring in your ecosystem of partners, and together we can develop these solutions. And you've seen the examples of how to actually do it in a scalable and cost-effective way. All right, so now that we've talked about all of these topics, all of these examples, you're probably sitting here and thinking, okay, Maciej, I got it, it's very exciting, but what do I do next? when I leave this room, what should I do? So here's my suggestion, 3 calls to action. The first one is, as you can probably expect, get familiar with these transformational technologies. So if you don't know them yet, learn about them. Internet of Things, artificial intelligence, blockchain, fog computing as part of a multi-cloud architecture. Not only learn about it, start implementing solutions based on them. As I mentioned at the very beginning, there are thousands of organizations around the globe that build solutions on at least one or more of these technologies. So let's learn from them. Let's learn from their best practices. Probably more importantly, let's learn from their mistakes. And let's get started on this transformational journey. So that's the first takeaway and the first call to action I would suggest. The second one is around innovation. If you have an organization that doesn't have innovation in the core, please do so. You can look at some of the programs that we do at Cisco and we'll implement something else, it doesn't matter, as long as you change the mindset from innovation programs somewhere at the edge to now innovation is embedded into everything that you do. Because by doing so, you will enable and you will empower your employees to be part of your digital journey and your customers' digital journey. And the third call to action is around co-economy. As you've seen the examples that we've talked about, it is so critical that we actually build these ecosystems and leverage these ecosystems. So for example, if you're a security integration company, you are a horizontal specialist, maybe you should find a different organization that is focusing on manufacturing and see if you can develop a solution together. Maybe you can find a regional partner who is focusing, let's say, on Chile, and the 3 of you, together with customers, can create 1 + 1 + 1 = 7. Does it make sense? All right. So now let's go back to the conversation that my son and I have been having about these epic challenges that we're facing as society and as businesses, from skills gap to hunger to poverty to government corruption to cyber wars and many, many more. As we discussed, technology has helped us a lot over the last 30 years to start addressing many of these challenges. We've seen great examples of networking technologies improving how we live as individuals, how we perform as businesses, and how we live as a society. But hopefully you would agree that both my son and I, we were right. The technology by itself is not sufficient. That we need people as well. And this is an opportunity. It's an opportunity for all of us. As Karen talked about on Tuesday, we have an opportunity to build a bridge between people and the machines, between businesses and the society. We can start building a bridge to possible, and we can do it together. Thank you so much.